Algebra 1, Common Core, Unit 1, Section 3, Order of Operations. So order of operations is how we simplify expressions. You see down here these types of things, and some of you may be in the habit of just typing them into your calculator, which your calculator can do for you. It can solve these as long as you type them in properly, and the TI-84 is very helpful for that. And I'll show you a little bit of that today as well. But you really do want to have fairly strong order of operational skills without your calculator, because there's a lot of times on tests where you have a long equation or something to do, and to take the time to type every little thing in your calculator really does slow you down, especially when you get to timed exams like SATs and things like that. Like, you need to be able to go fast. Plus there's a non-calculator section on the SAT these days. So you want to be able to do these things without a calculator, and in class tomorrow we'll be practicing this stuff again without a calculator. And ultimately, it's so you can do those types of things without a calculator. Because a lot of students, even if they have a calculator, will look at something like this and say, oh, I can do that without a calculator, but then they get it wrong. So, the calculator is a great tool, but we also don't want it to be a crutch. And, you want to have a decent foundational algebra base, which is going to make things easier for you. So PEMDAS is our acronym for parentheses, exponents, multiplication, division, addition, subtraction. And that's the order of operations. Now notice that these are not equations, these are expressions. And in fact, in the next video, we're talking about terminology and an expression versus equation type stuff. But in this video, we're just working with expressions. So there's no equal sign. We're not solving for anything. We're simplifying what we already have. Because when you go to solving equations, you actually do this backwards. But we'll get to that in another video. So for now, we're going to follow this. And what we do is first we look for parentheses. And we look to simplify any parentheses first. Then once we're done with that, and when I say look for parentheses, we look to see, what's inside here. I see a parentheses. So I want to do that math first. Even though addition is not before multiplication, because it's in a parenthesis, I'm going to do that first. So parentheses kind of override the rest of the rules. But once you simplify what's in a parentheses, then you do this. And from within a parentheses, if you have multiple things, you follow this process. So we look for parentheses first, then we look for exponents. Then multiplication slash division, addition slash subtraction. And that slash is, I think, where the confusion is, because people tend to think multiplication first, division after. That's not really true. Multiplication and division happen at the same time. Same thing for addition or subtraction, same time. You could kind of consider it as one operation, and this is one operation. And so these operations should be done in this order to correctly simplify an expression. However, multiplication and division have the same priority. They're completed in the order they occur from left to right. The same for addition and subtraction. So like when you see something like 5 times 5 divided by 5 times 5, if you were to multiply first, 5 times 5 is 25, 5 times 5 is 25, then you would divide and you'd get the answer of 1. This is wrong. That is not the correct answer. What you're really supposed to do is just multiply and divide at the same time, left to right, whatever happens first. So the first thing on the left is 5 times 5. See, that's underlined. Well, that's 25. Then I have divide by 5. Well, 25 divided by 5 is 5. Then I have another times 5. So the correct answer here is 25. So I multiplied, then I divided, then I multiplied. You don't do all of the multiplication, then all of the division. You do them in order left to right. And the same thing for addition and subtraction, which we'll see at our first example right here. 2 plus 2 minus 2 plus 2, right? I'm not going to do just 2 plus 2 and 2 plus 2 and then subtract. I'm going to do them at the same time. So 2 plus 2 is 4, minus 2 plus 2. 4 minus 2 is 2, plus 2 equals 4 as a final answer. 4 times 4 is 16, divided by 4 times 4. 16 divided by 4 is 4 times 4 equals 16. So very similar to the example you had up there. All right, what if I have addition, subtraction, and multiplication? Well, addition and subtraction happen left to right, but multiplication does come before addition and subtraction does. So because I have a multiplication in here, I need to do that first. So this is really 3 plus 2 times 2, which is 4, minus 1. And now it's just addition, subtraction, so I just go left to right. 3 plus 4 is 7, minus 1 is 6. Okay, here I see multiplication, but before multiplication, I got to do parentheses. And within that parentheses, I have 3 plus 2, so that is 5. Then times 2 minus 1. I multiply first, 10 minus 1, final answer, 9. And remember, you could pause this video at any time because I'm kind of writing and talking at the same time. It might be difficult for you to write and listen at the same time. So feel free to pause it at any point, write what you need to catch up. This way you can listen and not be consumed with trying to write so fast that you're not paying attention. All right, here I see parentheses. So I got to do what's in that parentheses first. And I see a 3 plus 2 in there. So that's going to be 10. And keep the result in the parentheses, because when something's up against parentheses like this, that 10, there's no plus or minus, that really means multiplication. So this is 10 times 5, but 5 is being squared. And PEMDAS tells us we have to do any exponent stuff before multiplication. So, and this is a common mistake right here. One of the very common basic algebra things is people will multiply 10 times 5 first and then square. That's not correct. This 5 is being squared and then times 10. And I want to do the exponent first. So this is really 10 times 5 squared is 25. 10 times 25 is 250. Remember, times 10 is a nice easy thing to do without a calculator. You just attach a 0 on the back. All right, again, I have parentheses, and within the parentheses, I have an exponent and addition. Exponents come first, so that 10 stays out there. The exponent for 3 squared is 9, because 3 squared is 3 times 3, right? Not 6, not 3 times 2. It's times itself, 3 times 3. That's what squared is. Plus 2, and then I got to simplify the parentheses all the way until I'm done with that. And 9 plus 2 is 11. Now I could do the times 10 to get 110. Here's a little division problem over here. Now notice that it's split up, and so I want to simplify the numerator and simplify the denominator, and then kind of simplify that first. So I'll kind of work with the pieces separately. Up here, I have an exponent I should work with first, this negative 2 squared. Now remember, a negative squared is something times itself, and a negative times negative is positive. So that's going to really become a positive 4. Negative 2 squared is positive 4. 4 times that minus 6 over 7 minus 2. Multiply before subtract. 4 times 4 is 16 minus 6 over 7 minus 2. And it's kind of like, you know, yes, we divide before we subtract, but it's almost like these are in parentheses because they're in numerator-denominator form. So I need to simplify that to 16 minus 6 is 10, 7 minus 2 is 5. Now I can divide down to get a final answer, 2. All right, the last thing I want to do here for this video is a little bit of substitution. So here we're saying like x plus y, x minus y, x squared plus y squared, and I'm telling you what x and y are. And so we want to do a substitution. And it's important that anytime you do a substitution, like I'm going to replace x with 5, I don't want to just write 5. I want to put it in parentheses. And then plus, and what am I replacing y with? Negative 1. It's important anytime you do a substitution to use parentheses, because a lot of times if you don't, you're prone to mistakes. And so it's really 5 plus negative 1, which is going to be 4. Here substitute x is 5 minus substitute y is negative 1. And this is one of those places where if you didn't do parentheses, you might make the mistake, because you might think it's just 5 minus 1. But you're subtracting y, and y is negative, so we're subtracting a negative. And we subtract a negative, we get that plus plus, so the result is 6. Here, y minus x, is that going to be the same as x minus y? No. Something called the commutative property, where the order in addition does not matter. X plus y is equivalent to y plus x. But for subtraction, that's not the case. X minus y is not the same as y minus x. And you'll see that right here, that x minus y was 6. Let's see what y minus x is. So y is negative 1 minus x is 5. I have negative 1 minus 5 is negative 6. So it's actually the additive inverse, which is another way of saying same number, opposite sign. Okay, just a couple more here, and then we're done. So I'll plug in here. This is a 5 plus y, so 5 plus negative 1, and then that whole thing's being squared. That whole thing comes out to be 4 squared, so that is 16. Here I have a 5 being squared and a negative 1 being squared. A 5 squared is 25 plus the negative 1 squared is positive 1. Remember, negative 1 squared, the negative squared is positive. Result, 26. The last one, 3 parentheses, x squared is 3 parentheses 5 squared, because x is 5, minus 4 parentheses negative 1. Replace y with negative 1. PEMDAS says exponents first before you multiply, so it's 3 times 5 squared, 25. And here this is a negative 4 times. I could keep that like this. And so now we do multiplication. Here's multiplication. Here's multiplication. 3 times 25 is 75. And negative 4 times negative 1, remember that sign belongs to that number. So it's a negative 4 times negative 1 is positive 4 for a final answer, 79. All right, now, I have no problem with you then taking out your calculator and checking these things, but you do want to try to strengthen your mental math skills because it's ultimately going to make things a lot easier. All right, that's it. See ya.